स्ट्रीम बोल बोल।
चल रहा है, चल रहा है।
हाँ, मैंने कुछ
हाँ।
बोला ही नहीं। अभी अभी आ रहा है। हेलो।
हाँ, स्ट्रीम पे आ रहा है, स्ट्रीम पे आ रहा है।
स्टार्ट करें।
यस यस, यू कैन स्टार्ट।
हेलो गाइस, वेलकम टू द PCD of Codeforces around 1047 div 3. So the first question is Coulard's conjecture. So basically we are given a number x. There was an initial number. This way we had done a procedure k times, and we got x as the result. So we could either divide the original number by 2 or set it as 3x plus 1. So we are given the number of time the operations were performed, the integer itself. So we need to return the one of the possible results. Now simply we can see that if x was even, we could have divided by 2. Would it be the same that I multiply 2 to get a possible number? So what I did was basically print x into 2 raised to k. Um, so yep. Any doubts? Never mind. Let's move on. Why 2 into k? Okay, so since we are given a result and after some k operations, we got an x. So we when we look at the first operation, if x is even, we could divide it by 2, right? So to get an x, we could always multiply by 2 and get an even number, which could have been one possible solution. So ignoring the second operation, we can also always perform the first operation k times, which is why we got 2 raised to k into x. The, there may be other possible solutions as well, but this was the easiest one that I thought of. Any other doubts? Hello. Okay. Um, let's move on to B. We are given a permutation of size n. We need to find a permutation Q such that GCD of Pi plus Qi and Pi plus 1 plus Qi plus 1 is greater than 3 for all 1 to n. In other words, GCD of the sum of any two adjacent positions should be at least 3. So in short, let's say we are given this permutation. We need to find a permutation such that the GCD of this um, the GCD of this and the corresponding permutation. So the GCD of phi plus a and 1 plus b should be greater than equal to 3. And we have to do this for all adjacent elements. So one possible approach was, can I make all the elements same such that my GCD will be the number? So in case of phi, I can write 1. In case of 1, I can write phi. In case of 2, I can write 4. In case of 4, I can write 2. And in case of 3, I write 3. And the sum of any two elements, corresponding elements, is always 6. And therefore, the GCD of any two adjacent elements is also 6. So one solution for this is we just print n minus a plus 1 for the whole permutation. So for this, we can just print this permutation and it works. Any questions? let's move on to C. Um, we are given two integers a and b, and first we need to choose an integer k such that b is divisible by k. Then you need to simultaneously multiply a by k and divide b by k. Find the greatest possible even value of a plus b. And if it is impossible, then output -1 instead. So we need to make a plus b even firstly. And we are given a and b. Basically, what is written is I can divide b by an integer k and multiply a by k. So basically, I can transfer any prime factor, or I can divide b by k, where k is any prime factor, and I have to multiply a by that same prime factor. So firstly, we'll come to the a plus b is even case. So a plus b should be even. So odd plus even is even. Odd plus odd is even. Even plus odd is even. Sorry. Um, odd plus even is odd. Even plus odd is odd. Um, even plus even is even. Odd plus even odd is even. So yep. Uh, so as you can see, a plus b must be either both odd or both even, right? So for a plus b to be both even, they both should have been even, or we could make them even by transferring a 2. हाँ हेलो. ओके, कहाँ से कंटिन्यू करना है? बी तो हो गया ना? हाँ. हाँ. ओके. So we are given two starting से, या फिर सिर्फ even even one person? So हाँ, okay. So we are given two integers a and b such that first we choose an integer k such that b is divisible by k. Then we can simultaneously multiply a by k and divide b by k. So in short, we take a prime factor k and divide b and multiply k by that same prime factor, right? So now the goal is to make the sum even. So focusing on that, even plus even gives even, odd plus odd gives even. So in the case of even plus even, I have to make this even. So in case of a odd and b even, I can just divide b by 2 and multiply a by 2. And if that becomes even plus even, then a plus b is possible. In the second case, both must be odd. So yep, moving to the first part of a solution. Uh, uh, if both are okay, actually, I wrote the code was basically this. If both are whatever, sort of, and just a second. हाँ, अरे मेरी फट गई एक second. Yep. If both are even, either I can transfer the two to make like both are even, then it is fine. Or either I need to divide b by 2 and make a into 2. So that is the first part of the solution. And in case of odd plus odd, what I can do is both are odd. So both of them give me an even sum. So if both are even, it is fine. Otherwise, b should have two twos. So b should be in the form of x into 2 square, or x into 4, which basically means b mod 4 equal to 0. Right? In this case, it is possible, and for other cases, it is impossible. Now, to find the greatest possible even value, what we do is, if the parity is same, right? If A and B are both odd or both even, it is always A plus B plus 1 if A was even, or else it was A plus B the whole by 2 plus 2. This part I got from observation. Huh. A cross B by 2 plus 1. Okay. My bad. Code खराब लिखा. Yep. It is A into B. I got this from. हाँ हाँ पता है थोड़ा बेटर लिख सकता था. हम्म. अच्छा okay A into B plus 1. Yep. So we do a floor division by 2 and we do a plus 2 after that. Again over here we do the same. So yep, I got this from observation. To be honest, I did not focus on the question that much. So yes. It- okay. We move on to problem D, where we are given an array A. Let that f of x be the number of occurrences of x in the array, right? So for example, for this given array, f of 1 is 2 because 1 occurs 2 times in the array. Okay. And then we have f of 3 is 1 because 3 occurs only one times in the array. Now we have to construct a array of size b, of array b of size n, and determine if the array a of size n such that f of a of I is b of I. So in short, um, let's say we are given this array. Hmm. We are given this array, and f of 1 is f of 1 is 1, f of 2 is 2, and f of 3 is 3. So we need to construct an array such that like uh, f of a of I equals b of I. So f of 1 gives 1. So here again f of 2 gives 2, f of 2 gives 2 again, f of 3 gives 3, 3, 3. So basically we need to count the frequencies of each object and map it to a number, um, such that we get an array B where f of a of I equals b of I for all 1 to n. If there is one constructed. Okay. So first we are given an array size n and the array A. Here, as we can see, there is no possible construction as there is just like four elements, and the sum of all frequencies is more than four. So, yep. Um, yep. So the solution was, I just make groups where each of the elements with the same frequency, I'm storing the index of that, and I'm checking if the size mod k um, in groups is not zero. That is, I can make uh, each element into groups of size k. Uh, then like check is false, and then I break. And if I don't make it in groups of size k, then I print l minus one and return. And then I basically start with one for each and every frequency for each and every element. I just make the element in groups of size k. So as you can see here, like I am given six times. So one, if I put six times, I get this array. So yep, here's the E. Yep, this is a very nice question. You are given an array of size A, array of size n, and an integer k. For each element a of I, you set a of I to max of um, like everything except a of I, right? So we need to find sum of all elements in the array after k operations. So let's run it on a test case. Let's say this is the test case: 0, 1, 1, 2, 3, 3, 5. Yep. So when hmm? Zero नहीं आ सकता क्या? हेलो आ सकता है ना? तो for this element 0, we need to find the max of this part excluding 0. So it is basically 1. Then again, when we exclude this 1, the max of the
Max is
remaining
zero,
array,
na?
huh?
Max is zero, na? If
हाँ,
you
max is 0
exclude
ना?
zero.
तो when I exclude 0, तो मेरा max is 0. When I exclude 1, my max is again 1, 2, 0, 1, 2, 3, 4. So my max is 4. Again, my max is 4 when I exclude this. When I exclude 2, my max becomes 2. When I exclude 3, my max becomes 4. When I exclude 3 again, my max becomes 4. When I exclude 5, my max becomes 4 again. When we perform this operation again, we get 0, 1, 1, 2, 1, 1, 1. And again, when we perform the same operation, we get 0, 4, 4, no, sorry, 0, 3, 3, 2, 3, 3. Um, Now we will notice a pattern 0, 1, 1, 2, 1, 1. So if you just see, it goes in a cycle like this. Th- Um, and this happens because like when initially in the first cycle, all the elements greater than the max come to my max, and all the elements that were duplicates become my max. Um, in the second operation, all of the elements that were my previous max become my first duplicate element. That is, for in this case, all the fours become 1 because it was the first duplicate element. Um, Sorry, my bad. Yep. Even 3 becomes 3, 3, 3, 1. Yep. So as we can notice, after 3 operations, this thing comes to a cycle of 2. So what we can do is brute force for 3 operations and get it for a cycle of 2. So since the indices don't matter, what I can do is first I sort all of this, right? And in each iteration, I count the frequency. Then I get the max from the frequency. And in the result, I just replace duplicates and my max by the max, right? The elements greater than my max and the duplicates by my current max. And like I do this for the first time, I do this for the second time, I do this for the third time. After that, since it is running in pairs, I just check for the parity, which parity is my k currently at, and I print it accordingly. Um, was I clear? Hello?
Do you are you deciding how many times to brute force, or it is always three?
It is always 3. It can be proven that. I'll tell you how. In the first cycle, like as you can see, or if you just notice, the elements greater than my max become my max, right? Because they have nowhere to go. The all the duplicates become a max because removing the duplicate does not affect the max at all. So yep, at the first cycle this happens. At the second cycle we have elements which are the max and like which contribute to the max such as 0 and elements which do not contribute to the max. So they all come down to the max. which is 0 1 1 1 1. Again, now the same thing happens, and wait, sorry, I'm my bad. This goes to 0 2. Wait, yes, 0 2 2. मैंने सॉल्व गलत किया था, I'm sorry, कट दैट पार्ट अगर चाहिए तो. हाँ, so this goes to this, right? um, and इसके बाद if you will notice तो ये वापस यहीं आ रहा है. Was I clear?
And
Hmm. Yep.
but it doesn't always oscillate for three now, because what if I take 0, 0, 1 and 2? Let's say this example.
This will become like max is 3 3 3 1 2.
नहीं,
In the first cycle. हाँ, 3 3 1 2. फिर again the max is 0, तो सारे zeros हो गए. And then फिर 1 1 1 1. And फिर again सारे zeros.
after 1 still 0, so मतलब वो दो
हाँ
दो के बाद रिपीट हो रहा है,
हाँ.
नॉट
And if you,
थ्री.
हाँ exactly, तो वो दो के pairs में repeat हो रहा है, right? So हाँ, so I make V1 k minus minus करता हूँ, V2 k minus minus, and then after getting V3, wait, हाँ, I just check for the parity कि like ये वाला array लगेगा या फिर ये वाला array लगेगा, बस.
Okay, okay,
um,
understand.
any other doubts? um,
मेरा डाउट है
हाँ, बोलो ना.
हाउ डू यू कैलकुलेट द
Could you speak a bit louder, please?
हाउ डू यू कैलकुलेट द मैक्स मुझे कुछ क्लियर नहीं आएगा.
You were asking how do we calculate, right? Am I correct?
हाँ, मुझे इसमें क्लियरली आ रहा था.
Okay. So what I do is, for any vector, this is a lambda function. I take an n, which is the size. I make a frequency map. For every element, I just map the frequency, and for I equals 0, I less than whatever, I just increment the max. So I get the max, right? So this is, let's say, n log n, because each insertion is log n, and I insert it n times. Then calculation of the max is also n log n. Could have been done in O of n, but yep. Uh, and then for each element, I just replace it by the max. So like ये भी O of n है. You got it now?
थैंक यू.
Uh, So yep, all clear for this question. Hello. Okay, let's move on to F, prefix maximum invariance. So basically, we are given um, two arrays x and y, right? And we are given another z, like we have to find the z, could be variable. Formally, this is the condition: max of um, x1, x2, x whatever till xi equals max of z1 to zi. That is, let's say this is a, this is x, this is y, and this is z. So the prefix max from this part should be same as the prefix max of this part, right? Should hold for each I 1 to m. and f of xy is the maximum number of positions where we can make z of I equals y of I over all possible arrays of z, right? So what we could, this is the condition. Yep. So f of xy is the maximum number of positions where z of I equals y of I over all possible arrays of z. Um, so now there's that. And you are given two sequences of integers a and b, both of size n, and we have to find this value. Okay. Um, right. So, yep. Like, so first, like to for this, uh, like it is sum of all L to R, like all sub arrays of like A and B. I have to find f of x comma y. So my first intuition would be to like would be an O of n cube solution where for all L to R in X, I just check if my Z, the maximum Z I can make such that f of x comma y is maximum, right? So for any given x comma y, right, um, my Z can be same as y, um, only when, just hold on. यार मैं थोड़ा वो हेलो मेरी फट रही है पैनिक हाँ बहुत आराम से बात कर रहा हूँ हाँ तो लाइक अगर मुझे z का हम्म yep, हाँ 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 माइक्रोफोन एक्सेस ऑफ कर दूं क्या एक से मैं थोड़ा नर्वस हो रहा हूँ बस एक लेट्स स्टार्ट अगेन पहला सोल्यूशन वुड बी एक n क्यूब का सोल्यूशन जिसमें मैं सारे सेगमेंट्स पे ये चेक करता हूँ कि मेरा जेड आई इक्वल्स वाई आई कितने पॉसिबल जगहों पे बन सकता है तो ये मैं कैसे इंश्योर करता हूँ ये मैं इंश्योर कर सकता हूँ अगर मेरा नोटिफिकेशन ऑफ कैसे करते हैं ओके हाँ अगर मेरा ए ऑफ आई अगर मेरा लाइक एक्स ऑफ आई इक्वल टू वाई ऑफ आई तो मेरा पक्का जेड ऑफ आई इक्वल टू वाई ऑफ आई होगा ही होगा एंड द सेकंड केस इज मेरा प्रीफिक्स ऑफ एक्स आई एक्स वन टू आई माइनस वन is less than equal to what I require x of I sorry greater than equal to x of I and like less than greater than equal to y of I as well कैसे करते हैं वही पूछ रहा हूँ मैंने किया हुआ है हाँ, तो ये क्या है हाँ फोकस भी कर स्टार्ट सेशन सीखा मैंने बट यस तो बेसिकली मेरा x का i कैन बी द सेम एज y का i अगर मेरा जो जो भी x का प्रीफिक्स है राइट मेरा प्रीफिक्स x का मैक्स इज ग्रेटर देन मेरा x का i and it is also greater than मेरा y का i in this case like समझ a is कुछ ऐसा ग्राफ राइट तो मेरा y का i like wait okay never mind अ, ये कंडीशन सबको समझा ना क्यों हो रहा है? हेलो। हाँ भाई, रुको फिर से रीस्टार्ट करते हैं। अम, समझाने में थोड़ी प्रॉब्लम हो रही है, बट हाँ, ब्रूट वाला मेथड, हाँ मैं मिक्स कर रहा हूँ ना सब कुछ, वही गलती हो रही है। हाँ, तो लाइक इस केस में मैं एक कोई भी सेगमेंट लेता हूँ एंड मुझे z का i बनाना है सच दैट f ऑफ एक्स वाई इज मैक्सिमम, ठीक है? तो वो मैं कैसे कर सकता हूँ? वो करने के लिए लाइक कंडीशन इज फॉर मेरा जितना भी पीछे का, लेट्स से दिस इज a, दिस इज b, दिस इज, अब मुझे c का i इक्वल्स b का i बनाना है, वो मैं कैसे बनाऊँ? तो मेरा प्रीफिक्स का जो a है, लाइक इतना पार्ट should be either greater than मेरा all, should be greater than मेरा b का i, should be greater than this value, and it should always also be greater than equal to this value. So greater than equal to both of these values, right? Only then can these two values be the same. And this is case one. So case one is the prefix of a ka 1 to I minus 1 is greater than equal to b of I, right? So then I can easily make this, and also it should be greater than a of I. नहीं तो wait, this in this case मेरा तो पक्का I can make c of I equals b of I, and in case 2, like if b of I equals a of I, then my prefix of uh, this same thing uh, should be less than um, a of I and a of I equal to b of I. So we have these two cases where like b of I equals c of I. इसमें कोई डाउट्स है क्या? हेलो। हाँ, ओके, चलो। तो for the brute force approach, I can check all of these segments, which will give me an n cube complexity. So another approach, what I can do is I can check कि मेरा b of I equals c of I कितने possible l and r के लिए मुझे वो देता है, like 1 देता है, right? So that is the approach like which I did. So now for the given segments, I need to find b of I equals c of I. So if they must be the same, तो अगर b of I equals c of I, right? तो मेरे r का तो कुछ प्रॉब्लम नहीं है, दिस कैन हैपन फॉर एनी r. So what I do is the number of possible sublengths, like subarrays, for which b of I equals c of I is l into r, right? Where the l is the number of possible lefts that are before I, and the number of possible r that are after I, right? So uh, and in this case there are two cases, right? So to find the number of r's in the number of possible subarrays, it is just a of um, like n minus I plus 1, right? और मतलब प्लस माइनस 1 ऑफसेट whatever. तो ये वाला जो पार्ट है, ये मेरे नंबर ऑफ पॉसिबल आवर्स हो सकता है. Now the problem is to find number of possible else, क्योंकि मुझे ये दोनों condition satisfy करनी पड़ी है, right? तो number of possible else में मुझे case 1 पे check करना है कि मेरा prefix should be greater than b of I, right? तो ये मैं कैसे कर रहा हूँ, मैं एक सेगमेंट ट्री बना रहा हूँ, मैक्स सेगमेंट ट्री, एंड उसमें मैं बस बाइनरी सर्च कर रहा हूँ कि फॉर अ सेगमेंट फ्रॉम L to I मेरा लाइक मैक्सिमम एलिमेंट b of I से बड़ा है या नहीं है, राइट? एंड जो मुझे केस 2 सेटिस्फाई कराना है, दैट इज इफ a of I equals b of I need to find the element, the prefix max that was just like before this. So I need to find an L. उस केस में I need to find an L such that L to I में कोई भी ऐसा a of I नहीं आए, I minus 1 में कोई भी ऐसा a of I नहीं आए that is like greater than a of I, like a of k नहीं आना चाहिए, that is greater than a of I. तो ये चीज नहीं आनी चाहिए, right? तो इसको भी कैलकुलेट करने का एक सिंपल सा तरीका was monotonic stack. So that is a standard like formula that just gives you the like next greater element. I think lead code का भी problem है. So using that technique, I just got the previous like lesser element या फिर कह लो next greater element, and using that I just got the number of L's and number of R's, which gave me I का contribution, right? So this gives me a contribution of I such that B of I is same as C of I. Uh, Again, now I just do a for loop for each L to R to get the contribution of every element and sum it for all segments. Bas. So here is the implementation. Uh, so yep. This is a segment tree ka template standard. This is a max segment tree. Okay. Then I just take the input. This is the like last lesser element जो मैं monotonic stack से निकाल रहा हूँ, and I'm making a segment tree, max segment tree, so that I can binary search for this case 1, right? So then here I am binary searching for the case 1 and I'm getting the number of possible else, right? So here, and then the second thing is if b of I equals a of I, right? I need to find the this part, like the a of I such that the last should not be the like element from L to I minus 1 should be less than equal to I minus 1. So I'm calculating that from the last, and बस वही है. The answer is number of L's into number of R's. बस done. Any doubts? Hmm.
Or complex, I don't know. I'll just share it so that you can see. And you can end your stream, I guess that's it. By the way, congratulate Taran for reaching expert in this contest, most likely. So, hey, ये कैसे? हाँ. Now wait, is my stream live? Hello, बोलो तो सही. Hello, hello.
Yeah, I can see. You can edit.
Yeah, cool. So now you have A, you have B. इनपुट एग्जाम्पल ही ले लेते हैं इसका. दिस वाज अ गुड एग्जाम्पल. So what I was thinking is if I am at a particular L, what is the score? What is the summation of f of L to R such that L ये है, R can be this. You can do this in the reverse also, doesn't matter, same thing. Now, how do I calculate that? One thing to notice, if I have some particular range and I'm starting at an AI, my the numbers have to keep for sure. Keep those like for like let's say I have A, B and Z, no, X, Y and Z. The first element AI, Z has to be Z का first element also has to be A1. Why? Because whatever else it is, वो max prefix max का condition will fail. After this, the next greatest, let's say AX, should also be present here. The numbers in the middle don't really matter. They have to be obviously between, like, lesser than A1, but so these numbers should be, AI should be less than A1, less than equal to. Yeah. So that is the main thing. Now after that, what happens is you go to the next one, AY, and so on. If you go in reverse and let's say you have some score which tells me answer at X. Answer at X is basically, if I start with L at X, what is my score for all the other R's? If I already have this, what I only need to calculate is this middle part. How do I update my answer and how do I calculate it? That is the main question now. So now let's say I have this count, let it be C and T. Let this be some particular variable count. One thing to notice, when this is, for example, if you will, for like in all the sub arrays R's, first you'll have this, then you'll have this, then you'll have this, then you'll have this, then you'll have this, something like that. Now, this is kind of weird and off topic. Like this is like wait, one thing to note over here is wait. Instead of this value, I mistakenly went into this. I have to find, like, there's also this, no, B of X, B of X. Now this is fine. Here I have to do A of X, but now there may be some value B of X which is greater, like B of J. B of J is greater than A of X. This though I can't take for sure. If I take this, then it will be a problem. So kind of like I didn't fix this approach per se, but if you kind of look into this, basically find this index, then these values you can just basically, you will always replace them with B of J, B of X, or B of J, whatever. This value you cannot replace with B of J. So, and there are some values in the middle also, and so on. Now, I didn't fix this approach, I didn't code this up, so I don't really dive further into this. I'll tell you why, but there is a solution over here also. I have seen people's submissions with this. So, main thing why I didn't go into this is I was focusing on the next problem. I felt that was way more interesting and it was underrated for me, so I just moved on to this because I like this problem. I got WS, but I have a verified code and I just didn't code it up. So I'll just explain this in brief how this works. This is a very long problem statement. Usually long problem statements kind of are something which people kind of tend towards not reading or doing whatever. But sometimes what happens is longer problem statements hide an easier solution behind them. You might say that for this question. I felt like that, but yeah, it depends on person to person. Now, how does question goes? You have a directed graph. It's a graph, not a tree. Okay, let's say like this is the graph. Now it's directed graph and it is mentioned it is acyclic. Where is it mentioned? Acyclic. Directed acyclic graph. That means there are no cycles in them. What happens is originally everyone is white. There are two people playing a game. We'll call them Alice and Bob. Alice's goal is to like now, and there is a coin, token, coin, whatever. Now this token, Alice's goal is to make token reach node without out edges. Pretty simple goal. Bob's goal is make token reach red node, any red node. Okay. Originally everything is white. There are some queries and all which make it red. But now let's solve a simpler question. Like there are queries on this and stuff. Let's not focus on this. Let's think, for example, you have a graph. You also have which nodes are red or which nodes are white. Okay, let's say this node is red and all the other edges are white. Now can you solve this question without any updates? Forget this. Just focus on this. What is the question? Wait, what happened? Wait. Without any updates, if I just have a question, for example, if the game starts from this node, who will win? Is it Alice or Bob? Alice starts, Bob follows. If anywhere the token reaches the red node, the game ends and Bob wins. If anywhere the token reaches a node without outgoing edges, Alice wins. Now, if I want to solve this question, there are some queries and all. How would you go about doing this? This is kind of a standard game theory question, and you can imagine it as simply as a DP. Now, DP of node, comma player. What does this denote? You're at this node, and the starting player is X. It's either Alice or Bob. So this is like 0 or 1, and this is 1 to n. Now for this node, all it depends on are the children. Okay, let's say these are the children. Now if just imagine, okay, let's say for example all of them are dead ends. Okay, all of them are dead ends. They don't have outgoing edges. So what will happen is this is a node which wins for Alice. This node wins for Alice. This node wins for Alice. Correct. Now, does it matter who the so now if the player here is Alice and he's at this node, Alice will win. Correct. But if it's Bob, Bob is guaranteed to lose. Does that make sense? basically, if all the nodes are end nodes and Alice wins them, then Alice, then DP of node comma player. If it's node comma 0, then Alice wins. If it's node comma 1, then it's a loss because Bob will lose this. He can't do it. He doesn't have any choice. But now let's add choice to it. Okay. Let's make this node red. Okay. Now, if it's Bob's turn, Bob will win. If it's Alice's turn, Alice will win. That's great. When there are two options, there is an end node and a red node, both win. That's fine. But now, imagine all of them are red. Now what happens? Bob will win, but now Alice loses. So what we summarized is, if all children lead to end, then Alice wins, Bob loses. If children has end and red node, both win. If all children red, Alice loses and Bob wins. This is like the word format. Now, how would you define DP states? Because at the end of the day, that is what you need to implement. So, DP of node comma, let's say 0. 0 denotes Alice. I'll just mention that. 0 equals Alice. 1 equals Bob. Now, for this to be, now this can be either 0 or it can be 1. It's either winning for Alice or losing for Alice, this node. How is it losing for Alice? All children, so now it is DP of C of 1 equals 1 for all children. What does this mean? For all children, if the child's node and Bob's turn is winning for Bob, then Alice doesn't have any option. Alice will lose, definitely. Otherwise, it's winning. Does that make sense? This is else. Now let's do for same thing for Bob. Node of 1. It will be 0 or 1. It will be 1 if this node is red or any DP of node 0 equals 0. This makes sense? And 0 else. Else it's always losing for Bob. So if you have just calculated this, now if you have a query ki you're at some particular node, you can just check DP of node of 0 because it's Alice's turn always from that node. So if this query wasn't there and you are already given the colored graph, then this is all you need. But now the problem is updates are happening. Things are getting colored. If things are getting colored, that means some values will change. So over here, for this example, this is basically, here also you have to say or this node is red. Yeah. So now for a graph like this, if this is red, so now if I just, I'll store 0 1. This is losing for Alice, winning for Bob. This node, since it has no outgoing edges, this is winning for Alice, losing for Bob. This node, this is winning for Alice, winning for Bob, because both are satisfied. Now if we just go through these conditions, 0 1, this is winning for Alice, but for Bob this is losing, because it is winning for Alice here and here. 0 1, this is simply losing for both, because it's winning for both over here. This has to be losing for both. And over here it is winning for Alice and Bob. Why is that? Because here it's losing for Alice, so Bob will also win. And anywhere it's losing for Bob, so Alice also wins. Now if you have these DP values, well, this is the DP values initially. Now let's say I add a red node over here. Let's say this node becomes red. What will happen? You need to update this. No, wait. Let's say this becomes red. What all nodes do you need to update theoretically? You need to update this, 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 this. Technically, the entire tree which is in the parent part of the node. Correct. But the thing is, if for example this becomes red, this changes this. Okay, now let's just imagine this node I updated. This is a updated node. Okay, and this has some incoming nodes, and those have some nodes pointing towards them. Now, if for example, ठीक है, जो भी, this is also a node, this is also a node. If for example, you updated this, this gets updated, this doesn't get updated, like the value remain as it is. If the value remains as it is, does this entire tree matter? If this doesn't change, this won't change. So you basically stop right there. And if this also stops, you basically stop over here. This also, for example, stops. You only travel the nodes which get updated. That is the key inside. Only travel nodes which get updated. If we just do that, what is the time complexity in general? Let's just see that, okay? So how is a node getting updated? How is a node getting updated? Either it's like when it's Alice's turn, it'll go from winning, like for Alice, it will only go from winning to losing once. After that, if it's losing, it can't suddenly become winning because you're just making a new node red. So only this happens, right? And for Bob, it will only go from losing to winning, because originally everything is losing and suddenly it starts becoming winning. Okay, but once it's winning, it's always going to be winning. Once it changes to losing, it's always going to be losing. Okay, so what is happening? For every dp of node comma player, it gets updated at most once. Yeah. So with this logic, and you're iterating their parents also, depending on that and all, it's so it gets updated at most once, but you will visit that node the number of children times, like, yeah. So overall complexity actually is O of n for all queries. This is the key insight, that if it's not getting updated, don't like stop the recursion there itself. If it gets updated, go on further and do that. I do updates. Now still the answering part remains the same. Answer is I just check this. So yeah, that is it. Do you have any doubts over here? Tarun, did you listen? Yeah. So if you want to see the code, I wrote it pretty bad and was getting WS, but yeah. Now I'll just explain this. If it's an update, you update node comma 0 and node comma 1. And what is this? This is basically a recursive function. If the player is 0 and it is winning for Alice, then only you iterate. If it's losing for Alice, you just stop there, because Alice can't win suddenly. Now if it's winning for Alice and it's Alice's turn, since toggle means you set that node to red, so you just make it losing for Alice, and for all the other children, if it was winning for Bob, you go there. It's losing for Bob basically. The this is like, huh. Basically, yeah. So if it's winning for Bob there, you losing for Bob there, you update it. If it's winning for Bob there, you don't update it. So that is where the condition is. RG is basically reverse adjacency list. And for Bob, it says the same if it's Bob's turn, and if it's losing for Bob, this is denoted as winning for Alice. That is why it's 1. But if it's losing for Bob, make it make it winning for Bob. And if it's winning for Bob, now go to the children, go to the parents, update the number of losing positions for the particular parent. If all of them are winning for Alice, winning for Bob, it becomes losing for Alice. So you just update that. Basically, go there or just don't. That's the only thing. Pretty small code. This is like the main observation key. First, you need to understand this DP, classic game theory, and then you understand this part, and then you just solve it. A lot of tree graph query problems with updates usually boil down to stopping the updates early on and still getting the answer done, so that the overall time complexity remains open. So that is where kind of I got the idea. My implementation was very bad. I don't know why I'm getting a WA over here, but I'm not doing this node comma this. I'm just storing lots of stuff, pretty complicated, so don't really need to dive into that. But yeah, hopefully you enjoyed this PCD, like you understood this. Hopefully PCDs are back. There was a break because I was interning, but yeah. See you, I guess, next contest.